Okay, so we're going to go through these, the second page of the worksheet from today. I feel like I should start fresh, so I'm just going to get rid of this stuff. And there it goes. Just to explain it right from the get-go. So the first thing to note is that in each case, we're going to be using the formulas that are up here, wherever they ended up. There they are. So it's those formulas. The sine of 2 theta is 2 sine of theta cosine of theta. And check it out. There's the cosine of theta right there. The sine of theta over 2 is going to be the square root of 1 minus the cosine of theta over 2, plus or minus. We'll deal with that. Cosine 2 theta is cosine squared theta minus sine squared theta. And then the tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared. So we're going to use those formulas for, in each case. The main thing that we need to know, though, I guess for everything except for number 6. 6 we can do without any extra work. We can just plug in this. We know that that the angle here is between pi over 2 and pi, which is a second quadrant angle, so the sine will be positive, and so I'm going to use the positive branch. So let's just go ahead and do this one. Just draw a line here. So we'll just do positive square root of 1 minus negative 3/8 over 2. We can clean this up a bit. So that's going to be the square root of, I'm going to multiply the top and bottom of this fraction by 8. And so when you distribute that 8, I get 8 there. The double negative becomes positive, and 3 there. And then 2 times 8 is 16. And that's going to be the square root of 11 over 4. Okay, now the rest of these are going to require me to compute the sine and the tangent of theta. So let's actually do that. In order to do that, what we're going to do is we're going to draw a triangle. I just did that the wrong direction. It doesn't matter. As long as you're consistent with the labeling, you'll be okay. So here, for example, adjacent over hypotenuse, negative 3 over 8. I realize this should be poking out the other direction, but it's fine. And then this, we're going to call this b. So we have 8 squared plus, is equal to b squared plus negative 3 squared. So 64 is equal to b squared plus 9. And b is equal to the square root of 55. Positive or negative square root, but since this is in the second quadrant, I probably should have drawn it the right way. Maybe let's just, yeah, let's redraw. There. Now that can be negative 3, and it makes sense. Okay, so this, because this is a second quadrant angle, you know that this will be a positive radical 55 over here. Okay, so that means that the sine, I guess we have that. So the sine of the angle will be radical 55 over 8, and the tangent of the angle will be radical 55 over negative 3. So 2 times the sine, let me do this in a different color. 2 times the sine times the cosine, which in our case, let's see, 8 times 8 is 64. Let's see, this can be 32 here. That's going to be good. All right, let's do this one. So this will be negative 3/8 squared minus radical 55 over 8 squared. just to review, I have the 55 over, radical 55 over 8 was the computed value of sine. Cosine was given to me. So this is going to be 9 over 64 minus, pardon me, 55 over 64. So that will be negative 46 over 64, I believe. You can simplify that if you want. I don't want. Okay, now this one, we're going to be using the tangent of theta, which was radical 55 over negative 3. Let me just double check that my memory is correct. It is. We have this tangent right here. So plugging in the numbers, let's simplify this. 2 radical 55 over negative 3 all over 1 minus 55 ninths. I think the easiest thing to do to deal with this is just to multiply everything by 9. So here's the way this is going to look. I'm going to multiply that times 9, and that times 9, and that's going to do this. We'll end up with negative 6 radical 55 because one of the factors of 3 from the upper 9 is going to cancel with that negative 3. You're left with negative 3. Then on the bottom, I have 9 minus 55. So negative 6 radical 55 over 46, and negative 46. So you could get rid of the negatives. I guess that's the least I could do, right? Let's also cancel the 2. And that gives me this. Okay, so next we're going to take a look at this second column. And so for this one, let me get rid of the stuff I've written there. We're going to have to draw a new triangle. As with the left column, we're going to be doing the same sorts of things. Obviously, we have the same, almost the same formulas to deal with. It's just the last one is a little different. And so the first thing, though, is to get our triangle. This is in the third quadrant. Whoops. So here is the third quadrant here, or at least the way I would represent an angle in the third quadrant. Here, let me draw the axes just in case that's confusing to anybody. Here's my axes. The literal angle is this, but I'm using the reference angle as a stand-in to draw my triangle, this so-called reference triangle. But so the tangent is 2 over radical 21. That's opposite over adjacent. But because you're in the third quadrant, both of those will be negative numbers. So opposite, negative 2, negative radical 21. From that, we can use the Pythagorean theorem. I guess we could just call that C. So C squared is equal to negative 2 squared plus negative radical 21 squared. So C squared is equal to 4 plus 21, which is 25. So that means that C is plus or minus 5, but we're dealing with the distance from the center there, so it's always going to be positive for the hypotenuse. So there it is. Now that we have that, we can compute the sine and the cosine. The sine is opposite over hypotenuse, and the cosine of this angle is adjacent over hypotenuse. And let's put that together here. This will be 2 sine of theta, cosine of theta. And so in this case, we have 2 times negative 2 over 25 times negative radical 21 over 25. I guess we can clean this up a little bit. 4 radical 21 over 625. I'm going to leave it like that. And I'm going to slide it over a bit. There. Okay, the cosine of theta over 2. So we're going to have to use the plus or minus. This is different from over here. Yeah. So this is plus or minus 1 plus cosine of theta over 2. And so here, this is a little difficult. We got to figure out where we are so that we can figure out what the half of this angle is. So anytime you're in the third quadrant like this, half of the angle will end up back here in this range. So somewhere over here. You see, if you think about it, half of 270 degrees is 135, and half of 180 degrees is 90 degrees. So you're for sure going to end up somewhere in there. You're going to be in the second quadrant. So that's important because that will help me figure out if my cosine is the positive or the negative. So in the second quadrant, the cosine will be negative, and so that will dictate this bit here. So negative, and then we have 1 plus the cosine was negative radical 21 over 25. And now we have to do a little bit of algebra or arithmetic. I don't know what you'd call this. Let's multiply everything by 25. So here's how I'm going to do this: is I'll multiply that by 25 and this by 25. And that's going to result in having 25 minus radical 21 over 50. Oh, you know what? We can't really simplify this much more. Yeah, there's not much else I can do. I suppose I could do this. Take this thing and write it like, I don't know, 1/5 or 1/10. If you multiply everything by 2, you get 100 in the denominator. So maybe that would make it look better. That would give me 10 down there, but you still have this ugly radical. Yeah, not much better. I don't know. I think I would stay with this one up here. Unless Pearson was being picky. And maybe you could make it a little cleaner. Okay, so cosine of 2 theta is cosine squared minus sine squared. And what that means is you're going to take that negative 21, radical 21 over 25, square it, and subtract off negative, what was it, 3? 2. Too many problems. And we're going to square that. So this will be 21 over 625 minus 4 over 625. And that gives me 17 over 625. Almost done. One more. We have the tangent of theta over 2. And I think that I will use this version. Which one was easier? Here. Is that one going to be easier, or is it the other one? Let's start with the first one. If things look ugly, we'll switch to the other one. I feel like when we did this in class, some people used the one that I didn't use, and it looked better. It was easier. So we'll do the first one. Okay, so let's see if I can write these in here correctly. So that's going to be over negative 2 25ths. Okay, so we have 1 plus radical 21 over 25 all over negative 2 over 25. Here I'm going to multiply everything by 25. So 25. And that's going to give me this. So 25 plus radical 21 over negative 2. And I guess that's about the best I can do. I guess I could put the negative on top. But I'm not going to get any better than that. All right, there's one more that's on this sheet, and it's just something that you probably could figure out yourselves on the homework, but I thought if we did one similar to this, that might help you out. So suppose that x is equal to 3 cosine of theta. I want to express sine of 2 theta in terms of x. This sort of thing happens every now and then when you're working with calculus, trying to rewrite a function in a maybe simpler form or a form that's easier for you to work with. So the key here is to rewrite this like this. You have cosine of theta is equal to x over 3. And then we'll use our little triangle trick. So x over 3 adjacent over hypotenuse. And that will, from that you can figure out that x squared, we'll call this b here for a minute. B squared is equal to 3 squared. That means that b squared is 9 minus x squared, and b is the square root of 9 minus x squared. So with that, we can figure out that the sine of theta is that radical over 3. And so I want to find the sine of 2 theta, and I do that by doing this. Sine of 2 theta is equal to 2 sine of theta times cosine of theta. So 2 times radical 9 minus x squared over 3 times x over 3. So that'll be 2x radical 9 minus x squared all over 9. And that's about as simple as it can get. All right, hope you enjoyed. Make sure you smash that like button.